Hello guys, this is the experimental setup for the heating chamber. Here is our DC power supply and here is the heating chamber, which consists of a halogen lamp at the top, a cooling fan at the back and a temperature sensor mounted inside the chamber. The temperature can be seen on this LCD and it also shows the error messages if there are any. Here is a toggle switch which is used to turn on and off the experimental setup.
These are the 4 LEDs in the system. The first one indicates whether the system is running or is in the disabled position. The second one indicates the working of the halogen lamp, and the third one indicates the working of cooling fan. The fourth one is to indicate whether the temperature has exceeded the maximum limit. This is the code that we are using to control our heating chamber. This is the knob which we use to set the temperature. This is the temperature sub VI, which converts the voltage from the temperature sensor into temperature value. And so this is the PID block for the heating lamp. This is the PID block for the cooling fan. This is the digital input you get from the toggle switch, hardware switch, and this is the software toggle switch, safety switch. And these are the PWM modules that we use to control the intensity of the lamp and the speed of the fan. So we've used UART for our LCD display, and this block runs the UART depending upon different conditions. This is the LabView front panel which we use to control our heating chamber. From the front panel, we can change the PID values of both the fan and the lamp. The LED is used to indicate the position of the hardware switch, and this is the software switch to control the system. This is the knob which we use to set the required temperature. The front panel display on here shows us whether the system is running or is in the disabled position. This is the waveform chart which we use to display the knob's temperature setting and the real-time temperature value from the temperature sensor. So as you can see, the white line represents the value from the knob and the red line represents the real-time temperature. If we increase the knob, you can see the white line shifting up. This is the current temperature of the heating oven. Using this knob, we can set the temperature up to 40 degrees. As you can see that the lamp is turned on and the LED 2 is on to indicate that the lamp is working. You can see the temperature is rising up to a steady state value and attaining that without any overshoot. We can further increase the temperature to 44. You can see that it does not overshoot when heating and it reaches its steady state value, and the lamp starts to get dimmer. The current temperature of the heating chamber is around 40 degrees. We use the knob to turn it down to 30. You can see that the fan is turned on and the LED number 3 is on. And the heating chamber is cooled down without any undershoot. And it reaches a steady state value after quite some time. As you can see that the system is running to reach the desired temperature. We can use the mechanical switch as a safety toggle switch to turn the system off when required. The lamp and the fan is turned on and the system disabled message is being displayed on the LCD as well as on the front panel. There is also an indicator for the switch. This happens in either cases when you use the software switch also. The system is turned off and you have a system disabled message. We have set the system to reach temperature above 55. As it's heating to 55, it's showing an error message. An LED 4 is on when the system is disabled. There's a fluctuation because it does not reach temperatures above 55 and it cools down immediately so that the lamp comes on again.